name is Candice and Moraga, and I'd like to welcome you to another installment of my adventures in my diabolical laboratory. Today I'm going to be doing a couple of different experiments. I'm going to be doing experiments on types of forces, and I've got a little project set up here for using these three different cups. Actually, I had to use a different one. That's one form of experimental error. I had a different paper cup that I was using that I had pre-measured some water into, and it started leaking through the bottom. So this is a different paper cup, and I'm not going to fill this one until right before I do it, but the plastic and the styrofoam appears to be holding just fine. Each of these cups I filled with 300 milliliters of water, and 1 milliliter of water is equal to 1 gram, so I know the amount of the normal force, which is the force of the countertop here pushing up on each of these cups, which is equal to the force of the weight of those cups pushing down. So now we're going to be studying force of friction, which is basically a coefficient of the normal force. We know that this tabletop here is, well, this countertop is relatively smooth, but it does, I'm sure, exhibit some amount of friction. It would probably be more if I had tile with all sorts of grooves or something like that. And I've got some different weights here that I'm going to be putting in each of the cups. I'm starting off with 300 grams in both the styrofoam and plastic cups, and I'll be doing the paper cup first at 150 grams, and then I'm going to be doing 150 grams in the styrofoam and plastic cups and 100 grams in the paper cup. Smaller anyways. These ones are almost full. This one's almost full. So what I've done is I tried to loop the string around the top, but they just slide down. So, and I'm like a little cat with a ball of yarn every time I'm working with string or fishing line. I mean, if you can imagine me detangling for like an hour prior to doing a lab, it's really ridiculous. I don't know how I do that. But anyways, I have this detangled string here with a little loop that I can then use this little spring scale, which actually measures in tens of grams, so I'll be measuring to a significant figure of, beyond that of uncertainty. But it looks like that might contribute to a little bit of error as well on calculations. But what I do is I use this and pull, and I measure the amount of force that I'm applying. Doing it along this way, I measure the amount of force that I'm applying when the force of the friction equals 0. That is the point at which the cup will begin to move. So that's what I'm going to be looking at. And I've already practiced doing that, and amazingly enough, I can do it without spilling water. I'm going to be doing a couple more experiments, but I'll just show you what I'm talking about, because this is sort of fun. Okay, let's watch this. The constant speed looks like 50. I mean, it varies a little bit. I'm supposed to be doing it at constant speed, but probably my hand's a little shaky because I had to hit off my inhaler. My neighbors are like smoking right in front of my air conditioner. So let's try that again. I'm doing 5 trials anyway. Looks to be about 50 again. You have to sort of be right over it. Let's try that again. Looks to be about 50 again. Okay, so I'm going to do that a couple more times. And then I'm going to do that with the styrofoam cup and the paper one. And I've got another section to this lab as well, which involves these coffee filters, which I have already pre-formed into a little coffee filter basket. Let's do that again because it's fun. Okay. Now this is 1 and this is 2. I have already measured using my tape measure the height of this countertop here, and it is approximately 76.00 centimeters, which is also equal to 0.7600 meters. That's a lot of zeros. I might just keep my figures in centimeters, so I'll get things all jacked up in my calculator, which my calculator just loves me. But anyways, I'm going to be timing with my little stopwatch the amount of time that it takes when I push these off like so. Ooh, how pretty is that? I'm going to time that, and then using that time and the distance, I'm going to calculate the acceleration. Now we know that acceleration due to gravity is 9.8 meters per second squared. However, on something that's this light and with this amount of surface area, the air resistance can get to the point where it even like just cancels out the effects of the constant acceleration due to gravity, therefore hitting terminal velocity. Now I, as a very experienced skydiver, know from my personal experience that generally when you're skydiving, that's around 120 miles per hour that you hit terminal velocity. Now, of course, it's the 200 mile per hour club for people who like to go into head dives, but you're also decreasing the amount of surface area when you do that, and thus decreasing the amount of air resistance. So I've, of course, come up with some ideas on discrepancies that you could get when calculating your acceleration in a simple, distance time with a stopwatch type of calculation versus maybe a more complex kind of calculation that might factor in some amount of friction due to air resistance, which can be a pretty big deal over large distances depending on the objects you're using. Then, after I do several trials between filter 1 and filter 2, pushing it off like that. So basically 2 filters is going to increase the mass, but it looks like it has about the same amount of air resistance in terms of just surface area and all that. But then we're going to do the same thing without measuring the height, this time from a higher surface. And at first I was thinking here, but then I was thinking, no, that doesn't seem as fun. So I'm going to do it from the top of my refrigerator. I'm not doing all these calculations right now because I'm trying to present to you what I'm going to be doing. But then utilizing that previously calculated acceleration, I'm going to determine to infer the height of this refrigerator from that. I'm assuming there's probably going to be some sort of percentage error there because of the amount of air resistance that we're going to be incurring. So this is basically my lab on type of forces, and I'll see you back again in another installment of my experiments with our Newtonian laws, and those are going to be pretty fun actually. Peace out!